Now we want to start putting what we know about each type of triangle into use. We will use algebra to help solve. I am not asking for just add, subtract, multiply, divide problems to figure out your answer. We must continue to use algebra so we're ready for next year. Equilateral, 3 equal sides, 3 equal angles. Why am I allowed to fill in a number? Well, every triangle equals 180, so I know the only way to split 180 equally into 3 must be 60, 60, and 60. Isosceles, 2 congruent sides, 2 congruent angles. I don't know what they are, so I have variables in. Scalene, 0 congruent sides, 0 congruent angles, all three different angles. So what if I have a problem like this? I have a scalene triangle. One angle is worth x, one angle is worth 2x, and one angle is worth 3x. Now first of all, if you're saying, well that doesn't make sense, this angle looks smaller than this one. It's not drawn to scale. So what can I do to figure out what the missing number is? What do I do to solve for x? I do know that every triangle, all three angles must add up to 180. So what if I write an equation with these three angles added up and equaling 180? So let's take the three pieces. I have x plus the next angle, 2x, plus the last angle, which is 3x. Now, before I solve it, I always want to try to shrink it down. Can I combine anything that is similar? Look at this side. X plus 2x plus 3x. Remember, these are terms. First term, second term, third term. What is the coefficient of the x? Coefficient is the number that goes in front of the variable. The coefficient of this term is 2. The coefficient of this term is 3. What number goes in front of the x? That's right, it's a 1. So can I combine 1x plus 2x plus 3x? The answer is yes, I can. Okay, they all have an x, so I carry the x. 1 plus 2 is 3, plus another 3 is 6x. On this side, I still have 180. Did I shrink this down? I did. So now I have 6 times a number equals 180. What is it? I need to get rid of a multiplied 6. What do I multiply both sides by? Please don't say the opposite. Opposite only works in adding. I need the reciprocal. Reciprocal of 6 is 1 over 6. If I do it to one side, what must I do? I must do it to the other side. 6 on top crosses off with 6 on the bottom. I'm left with x equals. Reduce 3, 0, and a 1. I end up with 30. Okay? Write an equation of a fact that you know. I know all three angles must add up to 180. Now, I am not done. Do you know why? I want to know what all three angles are worth. I figured out what x is, but that doesn't answer all three. If x is 30, go back to the original and say x now is 30. What is 3x worth? 3 times the value of x. 3 times 30 is 90. And again, you'll say, this doesn't look like a 90-degree angle. It's not drawn to scale. 2 times x, what's this angle? 2 times the value of x, 2 times 30 is 60 degrees. I am now done with the problem. The next problem we want to look at is, what if I have an isosceles triangle? Again, I'm trying to figure out what the missing angles are. In an isosceles, 2 angles are equal. It's not always the bottom. It just happens to be that's the way I drew them. But I do know that the angles opposite the congruent sides are also congruent. I could take this plus the top and equal it to 180. The problem is I have no idea what the top is. So it's tough to even use that. So I'm forced to use only two of the angles. Well, what's special about the two angles that are opposite of the congruent sides? They are what to each other? That's right, they're equal. So that means this value, which is 2 times x plus 40, is equal to 5 times x plus 10. So I took the bottom angle and set it equal to the other bottom angle, because I know they're equal. Now the question is, I need some solving to happen. Some of you have done this already, some of you have not. Okay? Here's what's different. Can I add these two together? No, I can't. Can I add these two together? No, I can't. The problem is I have variables on both sides of my equation. I must do something to get rid of the variables on one of the sides. Again, some of you have gone through this, some of you have not. This is an added 2x. The reason I'm picking the 2 is because it's the lower. This is 2x, this is 5x. I am going to pick the lower coefficient of the two. Of the two different. I want to get rid of this. What do I add to get rid of a positive 2x? If I do it to one side, I must do it to the other. So add negative 2x. What's the opposite of 2x? Negative 2x. Add it to both sides. Now let's do the left-hand side. What is 2x plus negative 2x? That's right, I get 0. What's the only thing I'm left with on this side? 40. On the right-hand side, can I combine 5x and negative 2x? The answer is yes, I can. What is 5x plus negative 2x? 3x. And I still have plus 10. Now this is better because now I have an equation with two operations. I need to get rid of the added number first. How do I get rid of a positive 10? What do I add to both sides? I'm going to add its opposite. The opposite of 10 is negative 10. 10 plus negative 10, 0. I'm left with 3x on this side. Negative 10 plus 40 is 30. Get rid of a multiplied 3. What do I multiply both sides by to get rid of a multiplied 3? The reciprocal. The reciprocal of 3 is 1 over 3. Do it to both sides. 3 up top crosses off with a 3 on the bottom. I'm left with x equals 1/3 times 30 is 10. I did solve for x, but I'm not done. Go back to my formula. This angle is worth 5 times whatever x is plus 10. X is 10, so 5 times 10 is 50, plus another 10. This angle is worth 60. Now, think about this. If this angle is 60, what does this angle automatically have to be worth? Remember, the two bottom angles were equal. 10. 2 times 10 is 20 plus 40, and this angle is also worth 60. Now, we can use logic here. Triangle's worth 180, 60 on the bottom, 60 on the bottom. Subtract from 180. The top angle must also be 60. And again, you'll say to yourself, but Mr. Long, they're all 60. That makes it equilateral. Okay, it's not drawn to scale. Two sides are equal. I didn't lie to you. I did have two sides equal. All right, I lied by putting this hash mark. But still, I can use the idea that they're equal to solve. This is our last problem we want to go through. Take a look at my triangle. What type of triangle is it? 3 congruent sides, three congruent angles. Equilateral, yes? There's a couple different ways to do this. I want to show you the fastest way. We do know that in any triangle, all three angles always add up to 180. I could write out a long equation. 4x plus 4x plus 4x equals 180. There's a much faster way to do it to solve for x. In an equilateral triangle, what does every angle have to be worth? Look back at your picture. Every angle must be worth 60. So, if I know that every angle is worth 60, let's write an equation. What is equal to 60? Well, what's this angle worth? 4 times x. So, I can simply say 4 times x, this angle, is equal to the number 60. And you would look at this and say, oh, I can figure out what x is. Okay, that's fine. Now show me algebra that proves it. This is a multiply equation. 4 times x equals 60. How do I get rid of a multiplied 4? Multiply both sides by the reciprocal of it. 1 over 4 on one side, I must do it to the other in algebra. Cross off the 4's. 4 on bottom crosses off with a 4 on top. I'm left with x. 60 times 1/4 should give me 15. Again, I solve for x. Now this is a little easier because I know each was supposed to give me 60. What's 4 times 15? 60. Done. So our job is going to be to use our ideas that we have. Equilateral, all equal to 60. Isosceles, two angles equal. It's not always the bottom two. It could be the right two or the left two. It's the opposite of the congruent sides. Scalene, none of them are equal, but I do know that all three add up to 180.